today we're going to talk about section 5.3. So we wanted to start with, what are all the things we know about the inverse functions? We know one, we switch x and y, which means we are really switching the domain and range. We know that the graph is going to reflect over the line y equals x. And we know that if we have our function, the vertical line test tells me that that's a function. But if we use the horizontal line test, and it passes through only once, then that means the inverse is a function. We could look at a couple examples. So let's think about a function that we do know are inverses, that we've worked with, y equals e to the x, and y equals the natural log of x. And if we look at those two graphs, so let's think, what does the graph of y equal e to the x look like? And if you don't remember just the shape of it, you could plot a couple points. If x is 0, well then y is 1. If x is 1, then y is e, which is almost 3. If x is negative 1, then I get 1 over e, or almost 1/3. And that should hopefully be enough to jar your memory that, oh yeah, that's y equals e to the x. Well, what about the natural log of x? Well, when x is 1, the natural log of 1 is 0. And we know they're inverses, so we could switch the points. This was the point 0, 1. Switch x and y, we get 1, 0. This is the point 2, comma, whoops, plotted it in the wrong spot. It was 1, almost 3. Sorry about that. A little crooked. 1 and almost 3. There we go. So 1 comma e. So that would be almost 3 and 1. There we go. This one is negative 1 and about 1/3. So we would go 1/3, negative 1. And that reminds us that that's the natural log function. If we look at that line y equals x, we can in fact see that if we were to fold the paper across that line, those functions would reflect. Now, the thing that we're going to be looking at here in section 5.3 is what's the derivative of the inverse function? So we can think about that maybe visually in this. If we picked a point, let's say we picked the point 0, 1. If I were to draw a tangent line here, and if I drew the tangent line, actually, let's pick a different point so it's more distinct. If I take this, that would be the tangent line there. The tangent line at the inverse point would be right here. So our question is, how do we think those slopes are related? So we're going to look at an example. Suppose we have the function y equals 3x minus 5, and we want to find the derivative of the inverse. Well, let's first find the inverse. We said this is my function, so to find the inverse, we're simply going to switch x and y, and now solve for y again. So we get x plus 5 equals 3y. We're going to divide by 3, which makes it 1/3 x plus 5/3 equals y. We're not going to call it y anymore. We're going to call it by the name of which it is, the inverse. So I'm going to write it up here. So here is my function, f of x equals 3x minus 5, and my inverse equals 1/3 x plus 5/3. So here, our question was, how does the slope of this line relate it to the slope of that line? Let's look here at this specific example. F prime here is 3. F prime here, alrighty, is a third. It appears that the slopes are reciprocals. Does that seem to make sense here? I think so. So at this point, I'm going to define the inverse, define the derivative of the inverse, and we can go back and look at a formal proof, but what we did find out was true is that the derivative of an inverse function is 1 over f prime, just the reciprocal. Now this piece we're going to explain in a minute, but if we want to put it in words, the derivative of the inverse is 1 over the derivative of the function at the x value when the y value is a. I can let you think about that for a minute, and we'll talk about how are the domain and ranges of inverses connected. So a couple things. If let's pick a we can pick on our 3x minus 5. That was f at x, and its inverse was 1/3 x plus 5/3. Let's pick some numbers for the domain. Suppose we had 0, 1, -1, 2. If I plug in 0, I get out -5. If I plug in 1, we get out -2. Plug in -1, I get -8. Plug in +2, I get out 1. What happens if I plug -5 into my inverse? Well, then I'll have -5/3 plus 5/3, and I get 0. What happens if I plug -2 in? I get -2/3 plus 5/3, which is 3/3, which is 1. If I plug in -8, you see the pattern? I should get out -1. Plug in 1, I should get out 2. And we notice that the domain here, what was the domain here, became the range over there. And what was the range here became the domain. So, if I asked you, or if I gave you A, this one would be F inverse at A. So, if I'm plugging in A, I get out F at A. So if I plug in A here, if that's my input, then that means A must be the output for my original function. And that's going to be a very, very important idea, that when I'm